Hello, hello. We are going to get started with the next one. So this is Stephen. Stephen's a software engineer with over 10 years of experience across the many commercial and consumer sectors. Great 10 years to his beautiful wife, Sarah, and 2 beautiful children. Currently works as a head of software at Rogo Ag. I know him personally, so I'm very happy to have him here. Very thrilled, and hopefully you guys find it valuable. Thanks.
All right, great. Hey, can you guys hear me okay? Is the mic working? Thanks for that. Didn't even do anything yet. Awesome. Okay, so today we're going to talk about leveling up your scripting. I joined the BSides Discord about maybe 8 months ago, and initially as a software developer, I was like, okay, this stuff's cool, but this is like a little tangential to what I do, but I just kind of watch and listen along. And then I noticed some people posting some Python scripts, and I'm like, hey, code's what I do. So I kind of looked at them, and I realized, hey, there's just some little simple things we can do to kind of clean this up, make these scripts a little bit better. So when they had the call for papers, I had an idea. I said, hey, you know what? I bet we can do a talk about some just quick improvements to Python scripting. I have a couple snippets that I basically pulled out of examples of code people's posted. So we'll go through that. I am going to go ahead and kind of, as we go to some examples, I'm going to start really simple. So some of you guys get really bored, like this is really junior stuff. I'm going to try to level that up as we go. So we'll start with the simple examples and work our way up to some of the complex. I'll have 30 minutes, so I'm going to talk really fast. I apologize. I will try to be clear and enunciate, and it's recorded later if you look at it for any other reason. First of all, I'm not worried about this thing because my son wrote me this beautiful card last night, and hope I did a great job. I just had to share that because it really touched my heart. So what's the goal of this? The goal is better scripting. That's really ambiguous. What does that even mean, right? I mean, there's no way to really nail that down. And as I was working through some of the examples, what I came up with is that I think we've all in here written some scripts, especially early on, where it's like a one-time thing, it's kind of hard-coded and hacky, and you use it, and then maybe 3 or 6 months later you go back to that script and you try to use it again and nothing works, right? Or you change system, nothing works on it, right? So I was like, okay, I think one of the ways that we can level up our scripting to do better scripting is to focus on maintainability. Okay, great, we're getting a little more concrete, but still a little ambiguous, right? What does that mean? What is maintainability? How do I apply that to code? We can kind of think of some examples, right? Can I hand this script off to another person and they can use it? Can I use it on a new target or a new platform? This is the big struggle, right? Can I run it or modify it, greater than 6 months after I wrote it? I struggle with this as well. And so, can we do that better? And when any of those things fail and I have to debug it, how easy is it to debug? So we'll look at some ways to improve that. But again, maintainability is still a little bit maybe ambiguous. There's an axiom in, I don't know if you call it an axiom, but there's a saying anyways, that it is easier to write code than to read old code. It isn't very true. I think if you've done any kind of development, you believe this, right? Someone gives you code, or you look at code you wrote a couple months ago, and it's like, what the heck was I thinking? Like, I don't even understand this, and you get this inclination, like, I'm just going to write it again, or I'll write a new one, or I won't worry about it, I'll do this task manually. You don't take advantage of that work you did. So here's where I'm going to dig down even further into maintainability, and that's why I want to write more readable code. We want to make our code more readable. And how do we do that? So here's some ways I think we can do that. I think less lines of code. Now, sometimes I'm going to talk a lot about Python. I think a lot of people use Python. That's not the only option. I think it's a great option, though, covering a lot of bases. Sometimes people in Python take this a little too far, right? You get these really clever little one-liners where someone's packed a whole bunch of iterations all into one line. And yes, it might be technically clever, but it's very hard to read. So there's a limit to this, but generally, if there's less code, it's easier to understand, right? If I give you a script right now that had 100 lines of code versus a script that has 1,000 lines of code, assuming they're roughly similar in complexity, the 100 lines of code is going to be way easier for you to get your mind around, right? There's just less you actually have to read. We want to actually have more verbose code. Now, this might seem a little bit contrary to what I just said, but what this means is we want to write our code in a way that it's clear what is happening, right? Python's great for this. Python reads really well when you use things like good variable names and good function names. If we start using short variables, short functions, it's much harder to read. So there's some ways that we actually want to make our code a little more verbose to make it more readable. We'll try to talk about some of those a little later. We want less obfuscated code. This goes back to the, like I said, especially with Python, we kind of have this tendency to write these really complex, dense things that are just, they're not intuitive, even to those of us that write Python or do programming in general, and it just takes you a lot longer to understand. And again, I'll give some examples of that. We want less interdependent code. So again, I'll show an example of this. Interdependent code would be, let's say, inside of a function, I have several lines of code, and if I were to, let's say, copy a few of those lines out, can they work on their own? I have a great example of that, and it's something that I saw in some of the code that I used as a motivation for this talk. And then also we want to do our code the same way we read everything. And this might seem super obvious, but I'll show why this is not always as obvious as you think. We want our code to be left to right and top to bottom. Now, again, I know that seems like super obvious, but we'll talk about why sometimes that's not always the case with some examples. Tooling, I'm not going to go into detail on this. I just want to talk about the tooling I used. I have personally loved using VS Code. I work across a wide variety of programming languages. VS Code gives me a really consistent editing experience. Doesn't mean it's the perfect choice, it's just a perfect choice for me right now. I think JetBrains is also a great one. So if you're looking to kind of up your development game, especially as it comes to Python, highly recommend PyCharm, the JetBrains IDE for Python. It's a great IDE, but again, VS Code, I've really enjoyed that as well. Generative AI, this is going to be a little controversial because some people are just like, oh my gosh, they throw their hands up, AI is terrible and it ruins everything. It really doesn't. I have actually used GitHub Copilot now for the better part of a year, and I have found it really, really helps my workflow. Now, to be clear, GitHub Copilot is not your normal kind of AI, prompt in a web browser, although I use those as well. GitHub Copilot for me is integrated into Visual Studio Code, and it reads my code and uses that as its syntax, and it actually helps me make really good suggestions on things in my code, and just kind of helps me add some boilerplate that I know I should have, but I don't always think about it in the moment, or I don't really want to write because it's so simple. So it actually saves me time. So I highly recommend using generative AI tools. Okay, I have cut down the slides down to just that because I timed myself last night. My lovely wife recorded me, and I had like 50 minutes of content, so I tried to cut my slides way down. So that's the end of the slides. So we're going to go ahead and do some examples. So this is Visual Studio Code if you haven't seen it. It's a great editor. I've got it blown up here, so hopefully we can see it here. I'm going to go ahead and run some examples that will show you the code that's running and also the output that runs from them. Again, we're going to start really simple, and we're going to work our way up to more complex. So early on, if you are a pretty good Python developer, you might think it's a little bit like, oh, this is really boring. For some people, these simple examples are really going to get them started and get them excited. So first, we're going to look at some language features. All right, I got to make this big enough too. That's pretty big text. We're going to make this a little smaller here so you can see it. All right. So some language features. This is a great example of the left to right formatting. One thing that throws people in Python, like, hey, I want to print a string for output, right? And you see at the top, we have some kind of classic ways to do that formatting, where you're using curly braces and placeholders, and those are fine, right? And they're still there for legacy reasons. But you notice, if I had multiple of those, I kind of have to read across my string, and I might look at my variables and back to my format, and look at my variables and back to my format. It's not really intuitive, is it? So we can make that a little better. We can concatenate our strings together with the plus operator, right? And that's a little nicer. It definitely reads left to right, but it's a little too much code, right? I've got these plus operators. I've got extra quotes in the middle. So the ideal, if you've never seen these, and some people actually really haven't, and so there's nothing wrong with that. Some people just don't know about some of these features in Python, is f-strings, right? F-strings are Python's implementation of what's called string interpolation. And this is where I can write a clever string, where I can write the string format, and then with that little f at the beginning of the string, I just have to do a curly brace, and I can put a variable right in there. I can even call other code inside that variable. That can get a little complex if you're not careful, but it's super helpful because that f string is very compact. It's very obvious what it's printing and how it's formatting. Super, super helpful to use f strings. I highly recommend that if you don't do that regularly. Make that a practice. It'll really improve your code. A little bit what I see a lot is sometimes we want to output multiple lines of text. So obviously I'm focusing here a lot on like command line applications, which is what I think a lot of us are going to use for various data applications. And so one thing I see is we'll put some text and then a new line character and text and a new line character, and you end up with this like 300 line, kind of multi-line printout, and it's really, really hard to debug. So you can actually use what are called block strings. That's where you do a triple quote at the start of your string block, and then you enter it down, and that actually will then format everything in as you see in the string block. Now, that's not ideal because you get these extra spaces here, and you can like bring that code back, but then it kind of makes the code weird. So we talk about left to right. If I'm going down a function, I'm kind of digging deeper, and all of a sudden my string block, kind of de-dents away from everything else, a little harder to read. So my preferred method, if I have to do multiple strings in an output, is actually you can start your print function, and then you can leave your parentheses open and just go to a new line, and just do more and more strings. You can do f strings, you can do regular strings, and it will automatically concatenate all those together. So this format here matches really nicely with what I'm actually outputting. And for me, that's very helpful. When my format matches my code, it's easier to debug, it's easier to edit, it's easier to see what's going on. So there are some string examples from the just language features. This is the with statement. This is another one I find that people are not familiar with in Python. If I have to open a file, right? You may have done this before. I say, okay, my file, is equal to open file name, give it some other arguments. I do some things in the file, and then I close the file. Nothing wrong with that, but if I would come in here, I was going to copy the open and the, some of the actions, and I didn't know that I had to close it as well, especially if I'm writing to the file. Now that chunk of code I pull out is not going to work as I expect, right? There's a subtle and a not obvious dependency between my file open and my file close. So with a with statement in Python, you can say with open, and then you give it the file information, and then you dedent in, and you do everything you do with that file. And it will close that file automatically at the end. So just by using the with statement that Python provides, I've removed a non-obvious dependency between those lines of code. So this is another, I think, really simple one that people maybe just don't know about and can really help improve your code. List iteration. This is another one to really make your code a lot nicer. So at the top is what I see a lot, where somebody would say, okay, for some index variable in the range of the length of my list, I'm going to go ahead and access the thing at that index. There's nothing wrong with that, but there's just a lot of words going on in that for line, right? Whereas we can actually do object-based iteration, where we can just say, for the item in my list, print the item. There's way less words there. It's way easier to read that. And even though I know Python, it's easier for my brain to quickly see what's going on, whereas for index in range length by int list, it's not as quickly obvious as I'm reviewing that code. There's also, this is a function that I actually didn't know about until a couple years ago. It's called enumerate. Sometimes we do need that index variable as we're looping through a list of objects. You can just wrap your list with enumerate, and it will return a tuple to you that you can unpack. So for index and item, in enumerate my list, and then you can actually have both the item and the index without having to add extra code to do the accessor. So it can just save you some lines of code and make your code a little cleaner and easier to read. So I'm going so fast, I'm out of breath, I'm so sorry. Let's talk about iteration for dictionaries, same kind of thing. So you can actually iterate through the dictionary by just using the same statement for key in my dictionary. Then it will give you each key as you iterate through it. And that's really easy, then I can access the value. But what reads even better is similar to the enumerate method. I can actually say for key comma value in my dictionary.items. And it automatically gives me the key and the value as I go through there. So again, just reads a little better, because now if I'm trying to evaluate something in that print statement, it's pretty obvious, okay, I'm printing key and value, right? I don't have to actually do that dictionary access. Just makes my code a little tighter, a little more compact, a little more readable. So. Truthiness, this is one you guys may or may not be familiar with. So in Python, obviously we know what a Boolean statement is, and we've all used them, I'm sure. That's what the whole point of programming, right, is conditional logic. But you can actually do conditional tests on things besides Booleans. Arrays, dictionaries, and strings. So your empty string, your empty array, your empty dictionary are all going to evaluate as false. That can be really helpful for when you're trying to just write some really clean, concise logic. Instead of saying, if length of array equals 0, which isn't bad, you can just say, if not array, and then you've got that false condition. This is one case, though, where I've actually found in some of the code that I've written in the last year, I've actually preferred to try to be more verbose. And I think I show this in the next example. So back to this truthiness idea. I can say, okay, here's my list. If my list, print list is not empty. If not my list, print list is empty. Sometimes what I'll do is I'll create an intermediate variable, where I'll say, my list is empty is bool of my list, which automatically does that truthiness check for you. Or my list is empty equals not my list. A little not as obvious, but then in my if statement reads really nicely, right? If my list is empty, do this logic. And so sometimes by making our conditionals a little more clearer to read, because that's usually the logic that trips us up, we can actually get code that's much easier to go back in, like, yes, I can see exactly what I was doing. I was checking if the list was empty. So sometimes adding a little code can help readability. Generally, I'm in favor of more compact programs, but this is an example where a little more code can be a positive outcome. So those are my language examples. Let's see how we're doing. Okay, we're making it. All right. So some standard library examples. This is a huge one I see, is that people will often try to concatenate paths. That's the obvious thing to do. I've got two strings for my path, I'm going to concatenate them together. Totally understand why that would be the first thing you want to do. Python is what's called a batteries included language. It has a huge variety of functions and tools to make your code better. One really simple one you can start using today is os.path.join. So the os module is part of the standard library, and the path submodule, there's a method called join, where you can give it any number of path-related chunks, and it will automatically put them together into a valid path, and it will take care of extra trailing parentheses, and it will combine them as you need to, and you get really nice output that's way, way more reliable, especially if you are writing some kind of a script where you give it a file or a directory as an argument, and like sometimes you have a trailing slash and sometimes you don't, right? This can just make things more reliable by using this built-in method to improve your code. Another one is line step. Again, if I'm writing code, like right now I develop on Linux all the time. I support people on Mac. I've used Windows a lot, full time in the past. It's so frustrating to take someone else's script or give someone a script that's on a different operating system and things are weird or don't format right. This is just another little tip that's right there in the standard library. It's os.linestep. So this will actually give you the correct line separator for both, whether it's Windows or Mac or Linux terminals. Windows uses /r/n, carriage return a new line. Windows will use new line. I think that's right. I might have that backwards. Either way, they're different, and this is a super easy way to try to get the correct output when you're trying to use a terminal and you're not always sure which environment you're on. Glob, this is one that I've used a ton recently. This has got to be one of the worst named modules in the standard library, because the first time I saw it, I had no idea what it was about. Basically, this just gives you a super simple wildcard search kind of functionality for file directories. This is so helpful. Every now and again, I have to pull out regex, but if I can avoid it, I absolutely do, because regex is just the worst. So this is a really, really great way when you're trying to list files or search for files. Just use the glob module. You can kind of use your standard asterisk wildcards that we're all used to in most search fields. Really, really easy way to be able to list a chunk of files. I use this today in production, actually, for something where I need to give a user a search functionality, and I accept a search string over an HTTP call, and I literally have the Python server in the back end just using the glob module to list the files. It works great. Okay, random. This is a fun little one. We've all probably used random numbers for various reasons. Python's got some really cool random stuff built in. In addition to the normal random number stuff, they've got random.choice. If you have a list of things and you want to pick one, that's a super nice built-in function. And random.shuffle, where you can take a list of anything and you can just mix it around. Super helpful if you're trying to do some testing and maybe beat your program to see what it fails on. So, all right, date parser. So now we're getting into some libraries that I have found crazy valuable in my work. One is date parser. Date parser basically takes any kind of a string and is super smart about turning that string into a date time. Again, if you're creating a command line interface for yourself where you have to like give some parameters and insert some logs, this is so helpful. Obviously, we've got kind of the normal date formats, and that's somewhat restricted to what your computer does, but you can see I gave it all sorts of formats and I had no problem with it. Additionally, you can give it things like today. Today is 7 a.m. Yesterday, an hour ago. Like, that is so awesome. When I'm trying to do some log searching and I want to throw some arguments in, that is so helpful. This library is honestly really slow. I will say that it's like one of the slower libraries I've used. But usually if I'm trying to just go and query some logs, it's still way faster than me trying to get the right format right for typing in my date time string. So date parsers are super helpful one I recommend. Let's see here. That was 4, right? I should have kept track of these better. So, all right, Rich, this is another one. Again, most of the time when I'm thinking about tools and scripts that we're writing, for me anyways, these are command line tools, right? These are kind of internal tools that I'm using for data manipulation tasks or report generation. One that's really helped me a lot has been Rich. Rich is a console library which can really improve your console output, and it shows it right here. This is also super easy to integrate today. You could literally take any Python script you have, install Rich, and then from Rich import print, and boom, you've got a lot of these features built in. So what you can see here, I print the normal hello world. I print hello world and I put some color and bold tags on it. It actually colors the output. I put a number in there and it colors a number differently. I put dictionaries, arrays, it colors them. I don't know about you guys, but for my ADHD brain, seeing these colors in the output just like makes things like that much more fun, right? It's like a game. It's like, oh cool, look at the cool thing I just did, right? So super helpful way to just really quickly improve the output of your script. I think it makes it more digestible, helps our brain get into what we're actually seeing a lot better. Another reason I love using Rich is they've got a function called inspect. Whenever you have like a library from like a vendor, like, hey, here's my Python library for interacting with my hardware. Inspect is a great way to figure out what's in there. There's functions built into Python that do this kind of thing, but inspect gives you it in a really nice, colorized, easy to read way. So you can see this is like the basic output where I can see the class type and I can see the data and I can get some other information. You can also tell it to give you all the methods. And you get this really nice output that shows you all the methods available on this object and how you can use them. It gives you any doc strings in there, if there's a chunk of them. This is super valuable for me. It just kind of helps speed up what I'm doing because I can more quickly understand what it is that I'm looking at as I'm digging through some code. And then, oh, this one didn't, it's too big. Let's see here. Let's see those formats right. Also, when you're trying to debug your code, Rich has a really great traceback function built in. So what it's doing here is I'm doing something where I'm adding together a number and a string, that's throwing an exception. So I print that exception, and you can see it gives me this really nice call location, gives me the exact error information, I'll colorize really nicely. And I can even then tell it to show me the local variables when I do that traceback. And so that not only tells me the exception, it also shows me what the values were when this exception happened. Sorry, this formatted a little weird here in the bigger screen. My number, my string, and so I can really easily see everything that's going on. And this just helps me in that debug cycle when I'm trying to improve my scripts and move forward. So, all right. Type hints. There's not much output in this one, so I'm going to actually show you this one in the editor. Now, for anyone who's done Python for a long time, this is going to be really controversial because type hints for a long time didn't really give you much, right? They were a feature of the language, but people didn't necessarily get a lot out of them. So, I'm going to talk about why I think they're super valuable. Primarily, they're valuable when you are using a modern IDE. So, for me in VS Code, here's what it does for me. So I've got two functions defined here. One is an integer function, just it takes an integer. So the type in you can see is this colon type syntax that I have over that. And the other just takes a string. In my editor here, I'm trying to call that function with a string, with an integer, those work fine. Here I'm calling that function with a number. Now, the type hints are telling me that this is wrong. It's telling me this isn't going to work. This function asks for a string, you're giving it a number. I can run this code right now in my Python interpreter and it will crash and throw an exception. This tells me, before I even run it, hey, this is wrong, this isn't going to work. And so if you just take the time to start adding some of these type hints to your code, and you're using an editor that's going to give you this kind of feedback, it can make your development cycle so much faster. I work a lot in JavaScript and TypeScript, and it's the same thing there. TypeScript is a superset of JavaScript that lets you add type information, and basically takes a lot of your error checking to what we would consider compile time. These aren't really compiled languages, but it's really taking your error checking to dev time. Because trying to fix errors and resolve these things at runtime is absolutely the worst. So I highly recommend you start using type hints, and I'm going to talk another reason why that's really great later. So on to example 6. Almost making it. Get done in time here. All right, so example 6, this is where type hints really come in clutch for me. Again, as I think about these command line applications that I write, these tools, these data processors that I use, they're often a simple CLI. No one else is going to use it. I'm going to use it. And I really want that CLI to not only be easy to use, but when I pick it up, 6 months, a year from now, I want to be able to get back to it easily. So this is where type hints really come in clutch. If you've done some Python for a while, you may have seen argparse. Argparse is built into the standard library. This gives you a really nice way to read in the command line, parse those arguments out, and use them in your code. So I'm calling the same logic function here. This one, they both just as a square of some number. The bottom example is called Typer. This is a library that I have used hundreds of times over the last year. What Typer does is I declare this global Typer object, and then when I define the function, I put type hints on those variables. And with just the type hints, Typer is able to basically introspect that code at runtime, and it gives me a full command line interface with autocomplete, with error checking, all those kinds of things without me having to do anything. So let's look at a more advanced example. This is based on something that came out of the Discord. Is Matt here? Matt, Rob? Oh, you're Matt. Okay, cool. So this is somewhat based off of a function that had, and I tried to basically take it and transform with a typer. So you can see there's a lot going on here. A couple things we have here. Obviously, we have simple typing of strings. We have some booleans in here. I'll show how those look in a bit. It can also do things like it can check paths, and you can tell, is this path a file, is this path a directory? And it will check that, and if it's not a file, and it should be, or it's not a directory, and it should be, or vice versa, it will throw an error. You get all that information just from the function definition, just by adding the simple decorator at the top and having the type wrap declared. This is so valuable. Let me go ahead and run this real quick, and I'll kind of show you what I mean here. So again, this is a bit of a long function declaration, but it just gives me a lot of things all built in. So if I run this, again, all that was just a function declaration. It's giving me all the arguments. It's telling me all the switches, what all the types can be. And this is just from running the command without the arguments. If I run it again and add the help flag, it gives me even more information. So I get the default types. I get the default values. I get options versus arguments. Arguments are required. Options obviously are optional. It tells me all the information I need, all from that actual single function declaration. what's really cool about this is that you can write small composable functions with command line interfaces by just adding the type or decorator, and now you can call those functions from other functions. So I have a file of probably at least 60 separate command line functions, all in about I don't know, probably maybe close to 10,000 line Python file, this function. That's all full of various data methods that I use. Pull data from our CRM, process it, print it out into a table as a report, and I can compose all of these together, and a lot of them have separate command line entry points. And so, again, when I think about the composability of this has been super valuable for my workflow, and I wanted to share that with you guys. So, all right, almost there, guys, almost there. Okay, so last one. So now we're still leveling up. This is probably one of the more complex topics, and this is one you guys might be interested in. Who here has heard of Python virtual environments? Okay, who uses Python virtual environments? I am very impressed. That is usually more people than normally do. I have always struggled with Python virtual environments. I don't know why. All of the syntax to make them work, I just like, I probably don't need it, right? Until a year down the road when I've installed 18 packages over 5 projects, and I try to upgrade one, and it breaks 20 other dependencies, right? So we're going to talk a little bit about how that works, because I think a lot of times I find that even among developers, people just don't dig in and understand how it works. So I'm going to try as best as I can to just give a little bit of the understanding that I have of how Python installations work and how virtual environment work, and how we can use that knowledge to help debug these kind of situations. So if I think about a Python installation, there's only a couple things I'm really concerned about. Usually I have a number of folders at the root of the installation, but primarily I'm concerned about the binaries and a library folder. In the binaries is the executables they would expect, right? Your Python 3, 3.9, whatever your version is, all get symlinked around, your pip binary, and other binaries that get installed. So this is what I'm mostly concerned about. And then the library package, I've got the site packages and other things in there that, again, I'm mostly concerned that's where my modules go. So the first thing that I usually do is I start to integrate PyEnv into my workflows. PyEnv is a Python version management tool. So as we think about what are these crucial pieces of the Python install, PyEnv literally just manages multiple copies of them for you. And if you set it up in your shell, it will let you basically use a single command to switch between versions of Python in your active shell. So for me right now, for instance, on our target machines, I've got Python 3.6. That's just the version there. I don't have a good way to upgrade it. Anyone who's used Python in the Linux version knows that's the case. You try to upgrade the built-in Python version, you're going to have a bad time. So this will help you not have a bad time in case you need to use another version of Python. The other thing I like to use is pipenv for managing my virtual environment. So just like the environment before, if you already knew about virtual environments, you probably know that literally all a virtual environment does is takes that copy of Python and makes another copy of it. That's all it does. It takes the basic install that you came with and it makes another copy of it. So you literally could actually have 50, 100 copies of Python on your computer if you have a lot of projects going on. Well, if you don't realize that's all that it does. What pipenv does is it gives me kind of a one-line setup that I can use to go ahead and create the virtual environment and manage the packages and everything else. And the only thing I have to change in my workflow is instead of pip installing a package, I pipenv install a package. That's literally the only difference. And so again, for me, mentally, because I kind of got used to Python as it is, that was a really easy transition from normal Python and installing everything into the global package structure to using separate virtual environments. So I found that super helpful as well. As you're probably realizing then, we actually can use these two in concert, which gets a little bit cumbersome, but it's not too bad, right? So you could actually have multiple global Python versions using PyEnv to manage them, and then you can select a specific Python version, make sure you have pipenv installed in that Python version, and then you can create a project, a virtual environment with pipenv out of that Python version. So by using these two in concert, it seems a little complex, and once you understand and think about how it's working, it's really not too bad. And this is the other reason it's great to use a modern IDE. I believe PyCharm does this the same way, but in VS Code, it actually does a really good job detecting this, and it will actually show me all my versions of Python, whether it's a virtual environment or a PyEnv version, and it does a great job managing these and letting me switch between them. So that works really well. All right, well, I have one or two little examples I thought about getting to, but I'm pretty much at time, so I'm going to just be happy that I ended at a spot. And yeah, I apologize for going so fast, but I had a lot to get through. Any questions in our last 30 seconds? Yeah.
Is there a place to find this online, like a breakdown? Or?
Yeah, so I have the slides in my GitHub, and I have the whole GitHub repo online as well. So that is here. Sorry, I don't have a QR code for it. I think we'll have a place to put the slides though, so these links will be up there. I've also taken a couple of repositories people have let me look at from in the BSides community, and I've kind of just made some tweaks around some of these things that I recommend. And it's just a nice way to see a real world example of, hey, let's make this script a little easier to call, a little easier to use in the future. So, anything else? Okay, sounds good. Thanks, everybody.
We are on break until 3 p.m.